In this little lesson, we are going to take a look at a whole heap of examples on how to graph sine and cosine functions. And I'm going to show you the basic idea using one of the base functions, in this case sine of x, over a single cycle, or single period, which is x is a member of 0 to 2 pi, so that's the domain, so we're going to graph it across that. And then we're going to apply the same principles across every single example that you can see here, plus a few more. So here we go. This is how I would do it. Sine graphs are symmetrical and follow a nice, neat pattern. So we've got between 0 and 2 pi. So what we do is we go to the end of our graph line, and you can see I've just drawn in my axes already just to make it a bit faster. And we will divide it off like so. 2 pi, and then we'll take half the distance between the y-axis and 2 pi, and we'll go pi. And then we will take half the distance again between each one. So that's pi on 2. And between these two is 3 pi on 2. So I've got all my little divisions here. Then I'm going to fill in with my amplitude, which for the base graph is just 1 to -1. Try and keep it pretty even if I can. Now, this bit's optional, but I find it really useful. Draw a dotted line as neatly as you can, just along the amplitude lines here. And if there's a translation, you'll also put a middle line in as well, but we don't need to do that for this one. Now I'm going to grab my dots here, and I know what my sine graph shape looks like. It goes from 0, and then it goes up to pi on 2, then it goes down to pi, then it goes down to 3 pi on 2, then goes up to 2 pi to finish. So I put my blue dots in, and then what I'm going to do is, rather than trying to do a sine wave like that, which I find tends to be a little bit tricky to get right, I just do it 1/4 at a time. And I know it doesn't look perfectly neat, but it does give the shape reasonably well. So we've got this curve here. Try that again. This curve here. And then it's going to go down to pi. So there's the other part of the curve there. And then I go from -1 up to pi, like so. And then I go from 2 pi to 3 pi on 2. Now, I know it looks a little bit wobbly. I'm writing on a screen, which doesn't help because my hand grips the screen a bit too much. But you can get a decent shape going there for one cycle. And P.S., this is quite a common thing to see. Graph it for one cycle, but it might not be. You might be told to graph it from -2 pi to 2 pi, something like that. But the same premise works. You basically, for the parts of the cycle that you have, you're just going to put in the x-intercepts here and where the maximums and minimums would be, and then you're just going to be joining it. So if I went to -2 pi, I'd be going down here, then up here, etc. Or if I was going to 3 pi, I'll be doing one more here, then one more here, and so on. So it's just a matter of dividing it up appropriately. Okay, let's have a look at the other examples. Now, in this instance, for every single time here, I'm going to assume that the instruction was to graph the equation for one cycle. And you kind of get to choose the cycle yourself if it says that. So one cycle for your basic graph is going to be 2 pi. Now, I haven't done any period changes for part 1 here, so it's still going to be a length of 2 pi. So I'm going to choose the easiest option, which is 0 to 2 pi, but I could choose minus pi to pi. I could choose lots of different kinds of periods, but I'm not going to. I'm just going to choose 0 to... So I'm going to choose 0 to 2 pi because, it's probably the easiest, really, if you can. So this time I've got 2 sine of x. It's not too much different. So I'm going to label one end with 2 pi, and then I'm going to keep splitting the difference. So halve it to get pi. Oops. Halve it again, pi on 2, and halve this side to get 3 pi on 2. Great, 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 great. The amplitude is -2 to 2, remember? So it's always, this is the distance away from the center. 2 units up, 2 units down. So I'm going to go from 2 to -2. And now I'm going to put in my little red dots here. Again, this is kind of optional, but I find it does help draw a neater graph. And I'm going to put my dots in. So from 0 to pi on 2, down to pi, down to 3 pi on 2, up to 2 pi, and then I'm going to draw my curves in. So I've got one curve going here. I'm not going to fix it this time. One curve going up here, one curve going here, and finally one curve going here. So our amplitude has been accounted for, and we've got our sine graph going. Nice. Next one, -2 cos of x. So same deal, isn't it, really? I've got an amplitude change here. I've also got a reflection that I need to take into account, but then I get to choose my cycle as well. The period length for cosine is the same as sine. It's 2 pi. So for ease of use, I'm going to go from 0 to 2 pi to capture one cycle. Same deal again. 2 pi over here, halve it to go to pi, halve it again, pi on 2, halve it again, 3 pi on 2. It's minus 2 is the value in front of cos x, so that means the amplitude is 2. So I put 2 up here and minus 2 down here. Again, it's the distance from here and here. Draw in my upper and lower boundary, if you like, if you want to call it that, I suppose. And away I go. However, we just need to take into account that it is reflected. So a cosine graph goes like this. So we're going to have to go like that instead. So instead of starting here at 2, we're going to start at -2. So I draw that in. And then next I'm going to be here. And then next I'm going to be up here. Then next I'm going to be here. And finally I finish here down here for 2 pi. And now I'm just going to draw my curves in like so. And then like so, and then like so, and then like so. If anything, this is not too bad. The main thing that causes this to be a bit of a problem is, I think, is because I kind of didn't really get my distances right in between. So, but it's good enough for a sketch, right? Okay, number 3, sine of 2x. Now, this requires us to think about a period change. So I am going to go period is equal to 2 pi, that's the usual period for sine, over 2, which equals pi. So we are only asked to do it for one cycle, and so I can go 0 to pi, and we're good to go. If it said you had to do it over 0 to 2 pi, then you would actually have 2 cycles, and so you would just repeat this for each length of pi. But it doesn't. Well, that's not how I'm doing it. I'm just going to do one cycle. So pi here, halve it, pi on 2. Halve it again, pi on 4. Halve it over this side, 3/4 of pi, or 3 pi on 4. Okay, so that's that bit done. Now we're going to do our usual. We're going to say, well, there's no amplitude. Well, the amplitude is 1, I should say. So we're going to go from 1 to -1. I'm getting a bit slapdash with measuring it off by eye, but I think it looks okay. And put my little lines in here, and then I'm going to just follow my patterns of dots. So sine always starts from 0, so up, so I go there, then it goes up to here, then it goes down to here, down to there, then back up to there. Draw my curves in, and there's one curve, there's another curve, there's a final or third curve, and there is my final curve, and that is my graph done for y equals sine 2x over 0 to pi. Again, if I had to do it again, if it was to 2 pi, I'll just quickly do it really quickly, not even properly. I would go, there's 2 pi there, so in the middle is 3 pi, and then I'd split these up as well and work out what that is, and then I would be doing more dots through here, and then curving it down, around, and up. So that's basically how I would do that if I had to do more than one. Okay, let me just get rid of that so it's all back to normal, or to what it was, and we'll move on to 2 more examples. Here we have a phase shift, sine of x plus pi on 2. Now, we know what the phase shift does. Because it's plus pi on 2, we know the graph has shifted to the left. So what I'm going to do is I'm going to take the old boundaries and I am going to shift them to the left as well, because I think that's probably the easiest way of doing it. So I shift 0 to the left, I'd get minus pi on 2. If I shift 2 pi to the left, I'm going to get 3 pi on 2, like so. So my domain for one cycle that I have chosen is minus pi on 2 to 3 pi on 2. And I feel like that seems about right. Okay, so it means that the next step is just a little bit more tricky, but we don't have to be too worried. Instead of going just over by 2 pi, I'm just going to have to be a little bit more careful. I'm going to go backwards minus pi on 2. And then I'm going to go forwards by 1 pi on 2, and then another 3 pi on 2. So I just have to estimate that as best I can. And I reckon that's probably about there, I think. 3 pi on 2. Then I'm going to split the difference between the two. So the difference between them is pi on 2. Like so. So it kind of means we've got 1 pi on 2, 2 pi on 2's in between. And then I'm going to split the difference again. So the difference between pi and 3 pi on 2 is just pi. And then we've got 0 as well, which I don't need to write in, I guess. And then once we've got those in, that's probably the hardest bit with the phase shift. It's just a matter of putting... Oh, sorry, I haven't done my amplitude, have I? How awkward. Okay, our amplitude is just 1. So we're going to go from 1 to -1, trying to keep it as even as possible. Pop in my amplitude lines. How about I call it that? My maximum minima. And now I'll put my blue dots in, and then I'm good to go. So I'm starting here, then I'll be going up to here, then I'll be going down here, then I'll be going here, then I'll be going up here. I feel like as if I've squished the right-hand side of my graph there, but it will give me a sense of what it is. So it goes there, and then goes there, and then it curves up there, and then it curves there. Yeah, it's a bit too thin to finish off with, but basically the graph is done. Okay, last one for this graph, for this little lesson is part 5 here, where we look at y equals cos pi on 12x. Really, this is the same as, let me see now, part 3, example 3 on this page. It's a phase shift, but it's a different one, so I thought it was worth looking at. If I look at the period of this one here, I have the period is equal to 2 pi, the usual cycle length for cosine, and I'm dividing it by pi on 12. Okay, well that's the same as 2 pi multiplied by 12 on pi. The pi's cancel out and I get a period of 24. So we've got 0 to 24. So maybe this is going to be a tidal graph or something like that over 24 hours. So we're using whole numbers instead of pi's, but guess what? It works just the same way. We go for the end of the cycle, which is 24 here, and then we split it, which is 12, split it again, which is 6, and the middle here, which is 18. It's cosine, and then we put the amplitude in, which is 1. So we've got going from 1 to -1 like so. Again, using my patented method. It's not original to me, but I do like it. I'll put in my dots in so I can sort of see how my graph will bounce up and down, and then I put my dots in. So cosine, it's not reflected, is it? Nope, it's not. So cosine starts up here at 1, then it goes down here, then it goes all the way down here before going back up and finishing at 24 where it started. And now I'll put my curves in, down like that, curve it through like that, and then finally finish there. And that is my graph done over a 24-hour period. There we go, 5 graphs, fairly quickly done, but hopefully enough for you to get a sense of how to do these graphs. I'll do another lesson where I put a few transformations in at once. The best I did with this one is just a reflection as well as an amplitude change here, but I'll do a few more, which include, for example, a vertical translation as well, and that's where things get a little bit tricky. So I'll do that in a different lesson.